Hello, this is Gary Marr from Red Oak Community College, and this screen captures from my JavaScript 1 class, CIS 166AA. What I wanted to talk about in this mini lecture is I want to expand about something I just kind of mentioned very quickly in lecture on Monday, and that was Trycatch Processing. Trycatch Processing is in every one of the C family of programming languages, C, C++, C#, Java, JavaScript. And what it's used for primarily is the processing of system-generated exceptions, runtime errors, situations where you divide by zero, or when you try to access an array that's its subscript is out of range. In other words, the array is not large enough, or it's maybe a negative number, something in that order, where the computer cannot actually execute the statement because one of the values is incorrect. The syntax is fine, logically it may make sense, but you're asking to do something, like in the case of divide by zero, that it simply cannot do. So it throws an exception. The exception usually corresponds to the type of error that you have. Divide by zero, subscript out of range, etc. These exceptions are always documented in the language API. These, I'll have to admit, are fairly rare in JavaScript. There's a number of ways to handle this situation. Typically, in most of your web pages, you can avoid a lot of these. But if you want to create a custom error message, which is a little different than a system-generated exception or a runtime error, this would be one way to do it with Trycatch Processing. So even though Trycatch Processing is primarily used for runtime errors, in this particular example, it's used for a custom error message. We don't do much, or haven't done much, with custom error messages yet in JavaScript. At least the ones we have dealt with, we probably just use an if statement and a document write or an alert box to display back to the user the error so they can correct it. In this particular case, what happens is a try block is marked off. It's marked off with the keyword try, or in cinnamon, and then two braces, which would mark the beginning and end of this try block, actually here and here. Inside the try block, okay, this program will be listening for exceptions or anything that's thrown by one of the statements. In this case, what happens is it checks to see if the acres box is not greater than zero. If it's not, it'll generate an exception by throwing this information to a catch block. There could be one or more catch blocks. If this was a Python also uses catch processing, or a Java class, I would show you multiple catch blocks here. Or what you can also do is have a generic catch block, which catches everything. And again, if I was to really talk about Trycatch Processing, this would at least be a whole class, and maybe a little bit later in the course. So what happens here is if the acres box is not greater than zero, then it'll automatically throw this message. The catch block will pick it up right here. It'll change a couple of variables, okay, one of which is to store the message in the message text. It'll change the acres box value, which has a number, to blank. And then this finally block is also connected with Trycatch Processing. The way the finally block is used is this is always executed, whether there's an exception thrown in the try block or not. So if it's a good value, it's going to get thrown. Excuse me. If there's a bad value, it's going to throw the error message. So if there's an error message, it comes down here. It sets a variable, sets a new value for acres complete. But most importantly, it takes that message, which was created up here, passed to it here, stored here, and uses it to display to the screen via the inner HTML call and basically show the error message to the screen. We'll see that happen in just a second. This is a very elaborate way of processing error messages for screen input. You can use this technique. There's other ways that work just as well. Trycatch also, again, is noted for, or at least is typically used for, processing runtime error messages, which, again, there's no syntax errors to the program. You're just asking the program statement to do something it can't, like divide by zero. That's not allowed on computers. So let's do this. Let's look at this again just for a second. A couple of variables inside a function called function acres. We're going to execute the statements in the try block. If there is an exception thrown, we're going to go here, bad data. If there isn't an exception, we're going to write down to finally. Finally will always be run. If there's an error, it'll be run after catch. And if there's no error, it'll skip the catch and go down to finally. If you go into the debugger window, turn on the debugger with a breakpoint starting at line 38, you can walk this through and see what happens. Okay, let me do this next. Let me go over to the actual page. Okay, and this is not real easy to show because they're using this special control, the slider control, to actually put the data. What I'm going to do is I'm going to go up to 1. I'm going to see a message appear. This is good data. But if I go down to, let's see, well, anything, 0 or lower, anytime I click this down button, what I have done, I've entered inside this catch block. A good data will see the statement, jump over the throw, and go right to finally and complete the message on the right side of the screen. But if I give it bad data, the message is going to change. And it's going to say, please use a number of acres greater than a 0. So again, let's do this one more time. We go back. If I pick a good value, okay, it's only going to execute the finally block of that try-catch block. And if I give it a number that's negative, it's going to start showing me the error message over here on the left-hand side, which is a clue for me to take and fix my input. Now, complicated topic. This is, exception handling and object-oriented programming are the two most complicated things with most contemporary languages. The good news is that Visual Basic, Python, C, C#, Java, JavaScript, all essentially use some of the same kinds of source code solutions using things like try-catch for exception handling. So you may have had some exposure to this to other classes, and if you didn't, well, if you're going to take C# or Java, you're going to see it again. That ends this video capture session. Send me some questions in Canvas, or we can talk about this again on Monday. Thank you.